What is gravitic propulsion? At its core, gravitic propulsion is about controlling gravity rather than working against it. Instead of using fuel to push a spacecraft through space, we could manipulate gravitational fields to propel the craft forward. Think of it like surfing on a wave. The surfer doesn't fight against the ocean, instead, they ride the energy of the wave. In the same way, gravitic propulsion would seek to ride the fabric of spacetime itself. While this concept may sound like science fiction, the foundational principles are grounded in well-established physics. In 1915, Albert Einstein revolutionized our understanding of gravity with his theory of general relativity, which showed that gravity is not a force but a result of the curvature of spacetime caused by mass and energy. Gravitic propulsion aims to manipulate this curvature, generating artificial gravitational fields that can influence the movement of a spacecraft. The science behind gravitic propulsion. To understand how gravitic propulsion might work, it helps to imagine a simple analogy. Picture a large, heavy ball placed in the center of a trampoline. The weight of the ball causes the fabric to sag, creating a deep indentation. Now, roll a smaller ball across the trampoline. As it approaches the larger ball, its path will curve toward the depression in the fabric created by the heavy object. This is similar to how gravity works in the universe. The mass of planets, stars, and other celestial bodies causes a warp in spacetime, and objects moving through it are influenced by that curvature. In the case of a spacecraft, gravitic propulsion would involve creating a strong gravitational field, much like the heavy ball on the trampoline, that warps the spacetime around it. By adjusting this field, the spacecraft could essentially surf on the curvature of spacetime, moving in any direction with minimal energy consumption. However, creating such intense gravitational fields would require enormous amounts of energy, likely far beyond what we can generate today. Why is gravitic propulsion so revolutionary? The appeal of gravitic propulsion lies in its potential to overcome the inherent limitations of traditional rocketry. Rockets rely on burning vast amounts of fuel to generate thrust, which makes them large, heavy, and expensive. This reliance on fuel also limits their speed, and the farther we travel, the more fuel is required, which creates a vicious cycle. As a result, journeys to distant planets take months, if not years, and the prospect of interstellar travel seems impossible. Gravitic propulsion, on the other hand, offers the possibility of continuous acceleration without the need for propellant. In theory, this would allow spacecraft to achieve incredible speeds, cutting travel times by orders of magnitude. For instance, reaching Mars could become a matter of days instead of months, and human missions to distant star systems might even be possible within the span of a human lifetime. This kind of propulsion would dramatically expand the boundaries of what is achievable in space exploration. Current research. A glimmer of hope. While gravitic propulsion remains in the realm of theoretical physics, researchers are actively exploring ideas that could bring it closer to reality. Several theoretical models are being studied, each with its own approach to manipulating gravity and spacetime. One such concept is the Alcubierre drive, proposed by Mexican physicist Miguel Alcubierre in 1994. The Alcubierre drive suggests that by compressing spacetime in front of a spacecraft and expanding it behind, a warp bubble could be created. This bubble would effectively allow the spacecraft to move faster than the speed of light, without violating the laws of physics. The idea is similar to the concept of a surfboard riding on a wave, where the craft itself does not move within the bubble but the bubble moves through space. Another promising idea is the Woodward effect, which suggests that fluctuations in an object's mass might generate thrust. This phenomenon has yet to be fully verified but, if proven, it could provide a practical mechanism for gravitic propulsion. Despite the highly speculative nature of these theories, the fact that researchers are pursuing them seriously signals that the idea of manipulating gravity is gaining traction in scientific circles. Warp drives and wormholes. Separating fact from fiction. The idea of gravitic propulsion is often tied to science fiction concepts like warp drives and wormholes. Both ideas are intriguing, but they raise important questions about the line between speculation and scientific possibility. A warp drive, like the Alcubierre drive, would theoretically allow faster than light travel by distorting space-time. However, this concept depends on exotic matter, hypothetical material with negative energy density, that has yet to be discovered. Until we understand more about the properties of exotic matter, warp drives will remain a fascinating theoretical possibility rather than a practical solution. Similarly, wormholes, shortcuts through space-time that could connect distant points in the universe, are also purely hypothetical. While they arise naturally from the equations of general relativity, their stability and the energy required to maintain them make them highly speculative. These concepts capture the imagination and inspire scientific exploration, but they are not yet grounded in reality. The future of space exploration. Endless possibilities. If gravitic propulsion becomes a reality, it could mark the dawn of a new era in space exploration. With the ability to manipulate gravity, humanity could reach destinations that were once thought to be beyond our grasp. Colonizing planets like Mars, establishing mining operations on asteroids, or even embarking on interstellar voyages could become feasible within our lifetime. But the impact of gravitic propulsion would not be limited to space exploration alone. The ability to control gravity could revolutionize many areas of human life. For example, it could lead to new methods of energy generation, transportation, and even advancements in medicine. The potential applications of such a technology are vast, and the benefits could extend well beyond the confines of outer space. Ethical considerations. Proceeding with caution. With great power comes great responsibility. As with any powerful technology, the development of gravitic propulsion raises important ethical considerations. The ability to manipulate gravity could have profound effects, not just in space, but also on Earth. Imagine the consequences if this technology were to be misused, either intentionally or accidentally. Given the potential dangers, it is crucial that the development of gravitic propulsion be approached with caution.